So far we have studied outcomes, sample space and events. Now in this video we will study algebra of events. So the first first algebraic property of event is complementary event. Suppose if we roll our dice and the outcomes we'll get are 1, 2, 3, 4, 5, 6. So if I define an event A, such that the outcome is only 2. So if 2 is the outcome, then the elements in the set A will be set A equals to 2. So there's only one element in this set, and this is our event A. And if I have to define its complementary event, so it will be A prime, which will contain all the outcomes except element 2. So set A prime consists only these all the 5 elements of sample space, but it does not contain element 2. So this is our complementary event. And if we have to find out the probabilities of each of these events, then it can be calculated as probability of A will be number of elements in set A upon number of elements in sample space, and it will be equals to 1 by 6 in this case. And in this case, the probability of A prime will be number of elements in set A prime upon number of elements in set S, which is 5 by 6. Now, if we add both these probabilities, then the sum we'll get is 1. And from here we can make an observation that probability of A prime is 1 minus probability of A, or probability of A will be 1 minus probability of A prime. And if we have to denote this complementary event in the form of set builder form, then we can write it as an outcome, event A prime or complementary event A prime contains an outcome omega, such that this outcome omega belongs to set S and it does not belongs to set A. And it can also be written as S minus A in the form of sets. So this was complementary event, and if we want to see this complementary event in the form of Venn diagram, then we can denote this entire box is sample space or universal set S, and this circle is our event. And if we have to find its complementary event, then the entire portion between box and the circle is our complementary event A prime. So this is complementary event. Next concept is the event A or B, and to understand this concept we'll again use the same example that we used previously, in which we rolled our dice and the outcomes we get are 1, 2, 3, 4, 5, 6, which form the sample space S. Now we'll define two events. Event A is a set of all divisors of 6. So in this sample space, the divisor of 6 are 1, 2, 3 and 6. And the event B is an outcome which is a prime number, and the outcome and out of this sample space, the numbers which are prime numbers are 2, 3 and 5. So this is our set B. Now we need to find event either A or B, or we can say we have to find event A union B. So in this event we'll carry all the events which contains in all the outcomes which are in the set A and all the outcomes which are in the set B, or elements which are either in A or B or both. So this is how we have to write event A or B, which is completely like sets. Now if we have to find out the probability of this event, then we can use the same expression, that is probability of A union B equals to probability number of elements in A union B divided by number of elements in set S. And in this set we have 5 elements, and in sample space we have 6 elements, so the probability of A union B will be 5 by 6. And if we want to extend it further, then we can rewrite this number of elements in A union B as number of elements in set A plus number of elements in set B minus number of elements in set A intersection B, and this entire thing divided by number of elements in set S. And if we combine these two, we get probability of A. Then similarly we'll get probability of B minus probability of A intersection B. Now if you want to calculate probability using this expression, then we can find probability of A as from here 4 by 6, which are written over here. Similarly probability of B will be 3 by 6, which are written over here again, and minus probability of A intersection B. So number of elements that will contain common elements in A and B are 2 and 3. So in these two sets, 2 and 3 are the two elements which are common. So the probability in this case will be 2 upon 6, and again the answer will be 5 by 6. And this is how you calculate probability of A union B. And if you want to write this event in the form of set builder form, then we can write it as omega is an outcome of event either A or B, such that omega is an outcome of event A, or omega is an outcome of event B. And we can also write this event in the form of Venn diagram, that is this entire box is a sample space, and this circle is event A and this is event B, and A and B will be the shaded region of these two circles. So this is the event A or B. Next we have the event A and B. So in this case we'll continue the previous example only. In this previous example we defined two events. Event A, outcome is a divisor of 6, and event B, outcome is a prime number. So the set A contains these 4 elements 1, 2, 3, 6, and set B contains these 3 elements. Now the elements which are both common in both these sets are 2, 3, and these two are called events A and B, which is denoted by A intersection B equals to 2, 3, and this is our this set represents our event A and B. And we can also find out its probability by using this expression, which is probability of A intersection B equals to number of elements in set A intersection B divided by number of elements in sample space. In this set we have only 2 elements, and in set S we have 6 elements, so the probability will be 1/3 for this case. And we can also write this event in the form of set builder form. So in this case omega is an outcome of A and B, such that omega is omega is an outcome of event A and omega is an outcome of event B. And we can also write this as in the form of Venn diagram, where this entire box is a sample space S or universal set, and this first circle is our event A and this circle is our event B, and the shaded part is our event A and B, which is A intersection B. So this was the event A and event B. Now the last concept is the event A but not B. So in this case we have to find only those elements which are part of set A only but not of set B. So in the previous example where we said that the outcome is an event is an outcome which is a divisor of 6, and event B, the outcome is a prime number. So in this case we want only those elements which are part of set A. So the elements which are only part of set A are 1, 6, because 2, 3 are part of set B also. So we'll remove all these elements from set A, and then we'll obtain set A minus B, which represents the event A but not B, and its elements are 1, 6. Similarly, you can also find out set event B but not A, which is B minus A, and then from set B we'll remove all those elements which are part of A. So in this case the B minus A contains only element 5. Now using this expression we can also find out the probability of event A but not B using number of elements in set A minus B upon number of elements in set S. And in this case this set contains only 2 elements and sample space contains 6 elements. The probability in this case would be 1/3. Now we can represent this event in the form of set builder form, and in this event omega is an outcome such that it belongs to event A but not B, such that omega is an event of A, element of A, and omega is not an element of B. Or we can also write this as omega is an element of set A and omega is an element of set B prime, that is complement of B, and this can also be written as A intersection B prime. And we can write this in the form of Venn diagram. So this is our entire sample space or universal set. This is set A, this is set B, and set A minus B would be this shaded region. Only that part has been shaded which is only in A. So this is A minus B or A intersection B prime, and this was the event A but not B.